Houthi F-18 Super Hornet with drones. Then this happened. March 20th, 2025. A formation of small drones appeared on the horizon above the Red Sea. Flying fast and low, they headed directly toward a critical U.S. Navy transit corridor. Launched from Houthi-controlled territory in Yemen, these drones weren't massive in size, but they didn't need to be. Whether armed or not, they represented a serious threat to shipping lanes, radar systems, and American forces operating throughout the region. The order came through immediately intercept. Within minutes, a U.S. A-18F Super Hornet from VFA-11, known as the Red Rippers, was airborne. But this engagement would be different. Instead of deploying a multi-million-dollar missile, the jet engaged with something far more economical and surprising: laser-guided rockets. The pilots selected a weapon system few expected to see in this confrontation: the APKWS, Advanced Precision Kill Weapon System. Originally engineered for helicopter platforms, it had been modified for high-speed fighter jets. Now, it would face its ultimate test in actual combat conditions. One by one, the drones were neutralized, quietly, cleanly, with devastating precision. No dramatic explosions, no excessive force, just efficient results. This wasn't merely about a single jet or one isolated interception. This represented a fundamental shift in strategy, cost-effectiveness, and the American approach to countering low-cost threats that continuously evolve. So why did the U.S. military pivot from missiles to rockets? What made this particular attack different from previous encounters? And what implications does this hold for the future of aerial combat operations? Let's examine the details. The engagement. The moment the FA-18F acquired its target lock, the nature of the engagement transformed. This wasn't the conventional dogfight scenario that pilots typically train for. There was no supersonic pursuit, no radar jamming, stealth warfare. The situation was both simpler and more unusual. On radar displays, the drones appeared as small, rapidly moving signatures. Their flight trajectories seemed erratic, likely programmed to create a swarm effect or to confuse automated defense systems deployed on U.S. warships. But the Super Hornet wasn't depending on shipboard defenses this time. It carried its own solution. From beneath its wings, the pilot selected an unexpected option: a pod loaded with APKWS rockets. These weren't heat-seeking missiles or radar-guided long-range weapons. These were upgraded 70 hydro rockets retrofitted with laser guidance technology, lightweight, cost-effective, and remarkably precise. With the drone locked in the targeting system, the pilot engaged. The first rocket launched cleanly, streaking through the atmosphere with controlled, almost silent propulsion. It didn't detonate spectacularly like a Sidewinder or leave a prominent smoke trail like a Tomahawk. It simply connected with its target. Drone neutralized. Then another drone followed the same sequence. Lock, fire, impact. Eliminated. The APKWS demonstrated not just accuracy but effectiveness that surprised many analysts reviewing the post-mission data. Traditional missiles represent overkill against small drones. They're expensive, heavy, and limited in quantity. With APKWS, however, the pilot could carry more weapons, engage targets more rapidly, and preserve high-value missiles for more substantial threats. The cost advantage? What made this encounter particularly noteworthy was its efficiency. In an era where military operations are evaluated by cost-to-kill ratios as much as raw firepower, using a $27,000 zero-cents rocket to neutralize a drone costing approximately $20 zero-cents suddenly became far more logical than deploying a $400 zero-cents missile. The Houthi drones had minimal chance of survival. Designed to exploit vulnerabilities in conventional air defense networks by being too small, too fast, or too economical, they now encountered a response equally agile and cost-effective. The result: a weapons system capable of striking within inches of its target without the financial burden or complexity of a full-scale missile. Even more remarkable is the APKWS origin story. Originally designed for helicopters and light attack aircraft such as the AH-64 Apache or the Marine Corps' AH-1Z Viper, it wasn't initially intended for high-speed fighter jets. But with emerging threats like drone swarms, Navy and Air Force planners recognized its potential. Integrating APKWS into platforms like the F-A-18 wasn't merely a tactical adjustment, it represented a budgetary revolution in combat operations. These rockets are undeniably lethal. They've proven their effectiveness in Afghanistan, Iraq, and Syria. But March 20th marked one of the first publicly confirmed instances of their deployment against drone swarms over open water from a high-speed jet platform. That adaptability elevates APKWS beyond just another weapon. It symbolizes a new paradigm in aerial combat. Not always bigger, not always faster, but consistently smarter. The evolving battlefield. For decades, U.S. fighter aircraft have been engineered to dominate high-end threats. Enemy jets, radar installations, advanced missile systems, but recent years have witnessed a transformation in battlefield dynamics. The most prevalent threat isn't necessarily another fighter jet, it's unmanned aerial vehicles. Small, fast, difficult to detect, and inexpensive. This changing reality forced the United States to reconsider its counter strategies. Launching $500,000 missiles every time a drone approaches a warship isn't sustainable. The issue extends beyond financial waste. It directly impacts the number of engagements a pilot can effectively address during a single mission. Traditional air-to-air missiles are heavy, limited in quantity, and engineered for peer-level adversaries. APKWS fundamentally changes this equation. With laser-guided rockets, fighter aircraft can carry more munitions, deploy them more rapidly, and respond proportionally to the threat level. Rather than using a $400,000 zero-cents missile to eliminate a drone assembled from commercially available parts, pilots can employ a $27 zero-cents rocket, a more appropriate match in both cost and effectiveness. The benefits aren't exclusively economic. Laser-guided weapons significantly reduce collateral damage risk. Their precision makes them ideal for engaging narrow targets because contemporary threats aren't always sophisticated, sometimes they're simply persistent. Achieving victory in such environments requires fighting more intelligently, not just more aggressively. Paradise shift. The March 20th incident didn't merely showcase a new weapon system. It revealed a fundamental shift in military thinking. For decades, air combat capabilities were defined primarily by speed, stealth, and raw power. Fighter jets were evaluated by maximum velocity, service ceiling, and missile system sophistication. But as battlefield realities evolve, so do the metrics for success. Today, the most effective aircraft isn't necessarily the most expensive. It's the platform that can engage the widest spectrum of threats with precision and economic efficiency. The APKWS engagement over the Red Sea represented a pivotal moment. It demonstrated that U.S. strategy no longer focuses exclusively on high-end dogfights or large-scale bombing operations. The future emphasizes adaptability. Modern missions demand the capacity to transition seamlessly from tracking a supersonic fighter to intercepting a drone the size of a backpack. Laser-guided rockets like APKWS provide pilots with that operational flexibility. Rather than reserving all high-impact ordnance for major targets, aviators now have access to intermediate options, weapons they can deploy quickly, accurately, and without concerns about cost, inefficiency, or excessive force. This transforms the approach to planning future air operations. Instead of preparing for a single threat category, modern squadrons train for multi-layered challenges: drones, fast attack boats, radar jammers, even cyber-linked UAV swarms. They require weapon systems with comparable versatility. The mission has expanded beyond air superiority. It now encompasses airspace management, operational tempo control, risk mitigation, and maintaining strategic advantage without unnecessary escalation. Military planners recognize that future conflicts will differ substantially from previous ones. Today's pilots train for scenarios where every weapon's release matters, tactically, financially, and politically. Laser-guided rockets have evolved from specialized tools to frontline options. This evolution is reshaping America's approach to aerial warfare. The strategic message: when a U.S. fighter successfully neutralizes enemy drones using laser-guided rockets, it represents more than a tactical victory. It broadcasts a strategic message that resonates far beyond the Red Sea. For the Houthis, the March 20th interception wasn't simply a setback, it served as a reality check. For years, they've exploited gaps in conventional defense systems. Their drones are inexpensive, mobile, and easily launched from remote locations. They've employed them not just for surveillance, but for strikes against commercial vessels, oil infrastructure, and even allied naval assets. Their advantage has traditionally centered on cost versus disruption economics. Spend $10,000, 0 cents, on a drone. Force opponents to expend $500,000 to counter it. But this engagement reversed that equation. With APKWS, American forces matched the low-cost strategy without compromising precision or operational control, dramatically undermining the Houthi tactical playbook. Proxy forces, including Hezbollah, Iranian-backed militias, and non-state drone operators worldwide, are closely monitoring these developments. Such groups rely on swarm tactics and asymmetrical pressure to stretch Western resources thin. The U.S. response wasn't to deploy larger ordnance, it was to employ smarter weapons. This type of engagement sends a clear global signal. Drone swarms will be met with appropriate and economical countermeasures. This fundamentally alters the risk-reward calculations for organizations that have long assumed the U.S. would only respond to major provocations. It also carries significant implications for state actors, particularly Iran. Tehran has provided support and drone technology to the Houthis, betting that inexpensive aerial harassment could tie down American assets and project regional influence. Now, that investment appears considerably less promising. A single F-A-18F equipped with precision, low-cost weapons successfully neutralized multiple threats without requiring carrier strike groups, counter-drone swarms, or prolonged engagement. Such efficiency makes escalation substantially less attractive for American adversaries and more hazardous for the proxies executing these operations. America's allies, nations across the Gulf region, East Africa, and the Indo-Pacific have observed U.S. responses to drone threats with increasing interest. The deployment of APKWS demonstrates versatility that can be scaled, adapted, and rapidly deployed. Beyond vessel protection, it's about maintaining credibility, the assurance that threats will receive proportional but decisive responses. In this context, the March 20th incident transcends military footnote status. It represents a strategic broadcast received clearly throughout the region and far beyond. The future implications. The March 20th encounter didn't conclude when the final drone was neutralized. In many respects, it marked just the beginning. What transpired over the Red Sea wasn't merely a successful operation, it was a validation test that produced outstanding results. Now that American forces have demonstrated they can effectively arm high-speed jets with economical laser-guided rockets, the question becomes, how extensively will this capability be implemented? We can anticipate more U.S. aircraft, F-A-18S, F-15S, even A-10S equipped with APKWS for rapid, efficient strikes against small mobile targets. This won't replace missiles or unmanned systems, but it introduces an additional response tier that bridges the gap between excessive force and operational passivity. Carrier battle groups are already reconsidering their weapons loadouts. Commanders now possess a proven option that's scalable, flexible, and significantly more affordable during extended engagements. This matters particularly in regions like the Red Sea, where threats tend to be persistent, low technology, and politically sensitive. Meanwhile, Houthi leadership likely finds itself reassessing drone deployment doctrine. What previously proved effective, cheap disruption through aerial swarms, no longer guarantees tactical advantage. If every drone can be countered rapidly and economically, the incentive for mass deployment diminishes considerably. We should expect tactical adaptations, stealthier drone profiles, higher altitude flight paths, increased GPS jamming capabilities. The technological contest continues, and American forces will maintain their adaptive posture as well. This flexible firepower capability aligns perfectly with evolving military concepts like distributed lethality and adaptive force packaging. Smaller units can operate independently with appropriate tools to address rapidly developing threats without constantly awaiting higher-level authorization or additional missile assets. The lesson is unmistakable. Modern warfare isn't exclusively about overwhelming force. It emphasizes precision, cost-effectiveness, and operational tempo. Through systems like APKWS, the United States has demonstrated its ability to excel in all three domains: faster response, smarter engagement without excessive expenditure. A single American fighter jet confronting a drone swarm employing an unexpected weapons system. March 20th wasn't about overwhelming firepower, it demonstrated the capacity to outsmart threats quickly, precisely, and with remarkable efficiency. Laser-guided rockets, like APKWS, are redefining operational parameters not just for pilots, but for commanders, strategists, and anyone studying contemporary warfare dynamics. In this emerging era, the side demonstrating superior adaptability often secures victory before adversaries can formulate their next move. What's your assessment? Does this represent the future of aerial combat where more economical, intelligent weapon systems perform tasks previously reserved for expensive missiles, or does this mark the beginning of another technological race between drone platforms and the countermeasures designed to neutralize them? Share your perspectives in the comments section below. If you'd like to support our channel more directly, consider joining the fleet. Members receive loyalty badges, priority comment responses, and help us deliver more authentic naval analysis and reporting. Click join on our channel page to become part of our community. Thank you for watching, and as always, stay vigilant, stay informed, and keep your eyes on the horizon.